A duct blaster is a small fan hooked up to the duct system, as well as a series of gauges used to test the tightness of the ducts. Duct tightness testing is relevant to weatherization because we can see exactly how much percentage of air is leaking through the ducts and how much is making it to the building. We're going to talk about how to conduct a duct tightness test or a duct blast today. We're also going to learn how to read the results and how to use the results from the duct tightness testing. Testing the tightness of a duct system in a home is important because it tells us how much air is being leaked through the ducts and how much air is being delivered to the specific rooms it's designed to. I have a whole bunch of different instruments and tools in front of me that are used during a duct tightness test. The duct blaster is the first and main item of the test itself. This is a fan that hooks up to the air handler or the duct system to pressurize it so that we can determine how much air is leaking through the duct system. The manometer is the actual gauge that we use to see specifically the quantity of air that is leaking through the ducts at a pressure of 25 pascals. This cardboard here is sometimes it's used to block off vents, sometimes it's used to hook up the actual fan to the duct system or to the air handler. This clear tape here is a self-adhesive tape that is non-marking and is a really instrumental tool in sealing off the return air vents specifically, and sometimes it's used to seal off the supply vents. We can also use a closed cell type of foam and cut it to the size of the registers and insert them in. We pull the registers out and push the foam block in tightly so that we don't leak air. This is a duct sealant right here that can be used to seal the ducts once we know how much and where the leaks are occurring. And these two different tapes here are just some examples of tapes that can be used to seal ducts as well as to install the duct blaster to do the testing. This is a flow capture hood that measures the quantity of air coming out of or going into a register. It measures it in CFM and is a quick way to see how well a duct system and forced air system is performing. We would use it to walk around to all the various rooms and test the airflows and add them up and see how that compares to the rated airflow of the forced air fan. There's a rating on the fan that says what the total CFM capability of that unit is, and we want to make sure that we are within a range of close to that rated CFM level. The duct blaster is a fan and does make a lot of noise sometimes during the duct blasting. We want to be careful to make sure that there's not anything in the way, there's no obstructions as we set up the duct blaster. And we want to notify the occupant that we are going to be making some noise in the building. The fan is used to pressurize the duct system, so making sure that there aren't any obstructions throughout the building as well as where the fan is installed. We'll have an electrical outlet turned on and plugged into this, and the speed control does make a little bit of heat, so you want to be careful to understand that it is going to generate some heat. And as always, we want to be very careful not to drop the equipment. It is all sensitive pressure measuring devices, and we want to be in a clean, dry place as much as possible. Sometimes we're going to be in a crawl space, so we need to find a dry spot to set up the fan and take care not to get any of it wet. The duct blaster is going to induce a positive pressure on the duct system. We are testing the tightness of the duct system. It is not going to change the pressure in the building because we want to have a window or a door open to the outside so that we have an even pressure throughout the building and that we don't affect the building's pressurization or depressurization. We will run the fan up to a level that reaches 25 pascals of pressure within the duct system and measure how much CFM is leaking through the ducts by using the digital manometer. Once we have a reading of what the CFM leakage rate is at 25 pascals, we can look at the total rated CFM of the duct system or of the forced air furnace and determine what percentage of air is leaking out of the ducts and what the percentage of air is being delivered to the building. The biggest asset of the duct blaster is that it allows us to shoot for a specific leakage rate. We measure the CFM of leakage in the duct system with the duct blaster and the manometer, and we can tell what percentage of air is leaking through the duct leakage and what percentage is making it to the building. The best use of this tool is to aim for a specific leakage rate in a percentage and try to get it down to that level to test the work that the crew has done in the duct sealing process. Preparing for the duct blaster is just as important as conducting the duct blast itself. One of the first things that we want to do in preparing is we want to shut the mechanical system off, the heating and cooling system off. At the thermostat, we can turn it in the off position. If we forget to do that and the system turns on during the duct blast, it will skew our numbers and we'll have inaccurate results. Next, we want to open the building to the outside, open a door or a window in the house so that we are measuring the duct system pressure with reference to the outdoors. It can be any window or door that's in the building so that we have that accurate pressure difference. One of the hardest things to do is to seal the vents off. We want to seal every single vent in the building, the return vents, all the supply vents. It can be very difficult sometimes to find exactly where all those vents are. A commonly missed supply register is in a toe kick under a cabinet in a kitchen or a bathroom. Taking as much time as necessary to find those vents will save time during the duct blast testing and provide us with the most accurate result of how much the duct system is leaking. We also want to remove the filter from the furnace. That obstruction will skew the results of the duct tightness test. So before we set the duct blaster up, we just slide the filter out and close the door where the filter is. This allows us to get the most accurate result possible. For this duct blast, the air handler is located in the crawl space. We did not have a return grill that allowed for adequate airflow with the duct blast, so we're going to be handing a bunch of items into the crawl space. We have the cardboard. I have my mask here and my coveralls for protection. We have the manometer that's going in. Some duct tape to help fasten the duct blaster to the air handler cabinet. This is the duct blaster inside of its case, being very careful. Having the proper protection equipment is important because crawl spaces can be a bit of a dirty environment and somewhat of a health hazard if we don't have things to protect our bodies and our lungs. So having good respiratory equipment is important. We also are going to grab the smoke pencil in here just to look at where the leaks are occurring when we run the duct blaster, and some more cardboard to help us with setting up of the duct blaster. Here we are in the crawl space. In this situation, we have an air handler located horizontally that we're going to be installing the duct blaster to. We have cardboard and tape and some other items so that we can attach the cardboard to it and attach the duct blaster to that to blow through the air handler cabinet and pressurize the duct system. The first step in this is to make sure that all of the power is off to this unit for safety. There's high voltage wires that come in here that can be a safety hazard. Not all situations are the same, so we want to be prepared for each home by having a number of items that we can use in different situations. Sometimes we'll be hooking up to a furnace, other times we're going to be hooking up to the duct system itself. So we want to be prepared no matter where we are. So now we're going to begin to assemble the duct blaster and mount it to the air handler itself. First, I got the ring that we're going to be using to attach to the cabinet. I'm going to mark it out. with a pen or a marker. And use a utility knife to carefully cut out the cardboard. We're having to do this, install this in this situation because we want to make sure that we don't have any obstructions in the airflow. And behind this cardboard we have the blower, which is a little bit too close to where the duct blaster would be. So we're going to mount this ring on with this short section of flexible ducting to give us a little bit of distance between the duct blaster itself and where we're blasting into the cabinet. I'm going to attach this flexible ducting to the ring, carefully sliding it over the outside of the plastic. It's kind of fragile, flexible ducting, so we don't want to tear it. And then this particular one has a small section of Velcro on it to be able to attach it. That's not always the case, so that's where the duct tape and some zip ties can come in handy. So now I have it ready to install, and I'm going to be using duct tape to attach it to the cardboard on all four sides so that there's no chance of it falling off of the cardboard. You want to keep in mind that we're using a nice, good quality duct tape because it's stickier and it lasts a lot longer. There's my final connection on all four sides, and you can see that it's sticking very well and it's not going to fall off. Now I'm going to attach the other side to the ring that is attached to the duct blaster. And this one I don't have Velcro on because we've cut this flexible ducting at some point. So we will have to tape this side to the duct blaster. You'll notice that the equipment and myself is in a nice dry spot, clean spot. We don't have a lot of dirt and debris around. It's important to keep the work area clear so that we don't contaminate the duct blaster itself. We're going to put as much tape on as we need to make sure that it stays secure. Dirt can accumulate inside of the duct blaster. There's some sensitive pressure measuring devices in here and in these rings, so keeping that clean is important to achieving accurate results. Now we're going to attach the ring to the fan using the provided straps that come with the duct blaster. Getting it nice and snug and tight and stretched out as far around the duct blaster as possible. You can see that we've achieved getting very close to getting all the way around. If there's a large gap here, we know that this is very loose and it's not holding on very well. Now we're going to hang this from this bar so that we have a nice clear path for the air to flow through the flexible duct and into the duct system. Now we're ready to hook up the cords and begin to assemble the manometer. Here's the digital manometer that we've been using for a number of different tests and the hoses that we're going to be using. we're going to be on one side, we're going to be attaching to the input. And this is used to measure the fan pressure, which will give us a CFM flow reading. On the other side of the manometer, we have the other tube, which we're going to be inserting into the duct system with this pressure port. This has a couple of tubes that we want to put in the direction of the airflow as the air is flowing past it from the duct blaster into the system and past this tube to measure, to make sure that we get to the 25 Pascal pressure measurement. We're going to try to find a hole in the duct system, which there's one right over here that we can insert it into. If there's not a hole nearby, you can drill a small hole, a 1/4 inch or 5/16 inch hole, to insert this into. Once we've completed the duct blast, we want to seal that hole back up. Now that we have a fan hanging from the floor and our tubes from the manometer, we can hook up the speed controller. The speed controller is what's used to vary the speed of the fan when conducting the blower door duct blast test. We have it plugged into a cord. We started it in the off position for safety. Sometimes in the bag this can get knocked and come on, so before you plug it in and attach it, you want to make sure that it's off. Now we can turn the digital manometer on, and we're going to configure it for the device that we have, because this manometer can be used for blower doors and duct blasters and a number of other instruments. So we set it to the duct blaster device, and then we're going to set it to the ring that we're going to be using. There's a number of different airflow size rings for the duct blaster. This ring, you can see, has a pretty large opening in it, which is used for systems that have a lot of duct leakage. Some of the larger systems or systems you anticipate to have a lot of leakage, this would be a great ring for that. That's ring 1. This ring here has a much smaller one. Smaller hole in it, restricts airflow, and allows a lot less air through it. This is ring 3, and then there's also another ring here that's in the fan, which is sort of in between the two, and that's ring 2. So I'm going to configure this for the duct blaster with ring 2, and we're ready to turn the duct blaster on and begin to pressurize the duct system. We're going to pressurize it to the 25 pascals of positive pressure with reference to the outdoors. So the building has been prepped. We have all of the ducts sealed off, all of the vents sealed off. The filter we have taken out, and we have an opening to the outdoors. In this crawl space, sometimes it's tough to find an open or a way to get to the outdoors. So you can use a tube to run from the digital manometer all the way to the outdoors using a small hole to get to the outside so that we can have that pressure reference of the duct blasting with reference to the outside. In this situation, we have an opening to the outdoors, so I'm ready to turn the duct blaster on.